This is Christine Johning in Lab M05 with my extra credit on the Physics of Baseball lecture. The basics included that the presenter was Alan Nathan from the University of Illinois. His original research was analyzing small atoms, and then he transitioned to baseballs, which are a much larger scale. He utilized slow-motion videos in order to determine what was occurring, and it still applies the same physics ideas from atoms and baseballs. In a ball-bat collision, you can see from the slow-motion videos that the ball deforms. This occurs because the friction from threads rubbing together decreases the energy of the system. After the collision, the velocity of the bat decreases and the speed of the ball increases at a different direction than it initially had. Large forces over a short period of time allow the collision to show how quickly it occurs. The velocity of the bat is important. It is determined by the pitch speed, the bat speed, and the collision efficiency. It is more important than the velocity of the pitch. Each mile per hour of the bat velocity is worth about 6 feet of distance, and each mile per hour of the pitch velocity is only worth about 1 foot. The collision efficiency depends on the coefficient of restitution. It includes the moment of inertia of the bat, so the shape of the bat is very important. A large inertia occurs when there is more weight in the barrel, and the bat velocity is determined by the inertia of the bat. The bounciness of the ball. The baseball only has an approximate bounciness of 1/2, which means that it can only bounce to 1/4 of its initial height. So this means that 3/4 of the energy is lost or otherwise converted to another form of energy. There is a sweet spot on the bat. This is a spot where less energy is lost, meaning there are less vibrations. You can hear when this is occurring because it feels best to the person who is hitting the bat. We are able to hit the ball farther when you are hitting with the sweet spot. And I have video clips. You can see in this clip that the bat vibrates greatly when the ball is coming into contact with it and the collision is occurring. In contrast with this clip, where the bat does not bend and it has a straight-on target hit with the ball. Breaking bats. A bat struck at the barrel shows that the handle moves after a noticeable time delay, especially noticeable when you're looking in slow motion. And the collision ends when the reflective waves have reached the barrel. The handle portion of the bat does not matter, so you can disregard the knob, handle, and grip. I have another video of this, and you can see a vibrational way that the bat vibrates because the energy is so great and it cannot transfer straight down into the handle. Aluminum bats have a lower moment of inertia due to weight distribution. This allows a higher bat speed and a lower collision efficiency. Hollow bats have a trampoline effect, and less energy goes into the compression of the ball. The NCAA regulated bats in 2011 due to the improvements in the physics of bats. Too much research was gone into how to maximize the distance that the ball could travel, so they have regulated the bats, which led to a decrease in about a factor of 2 in the number of home runs hit. Spinning baseballs. You can loosen the string to get a higher speed on swerve, and drag slows the ball down. The magnets and gravity deflect the ball from the straight path, and bad approximations occur when drag is neglected because it has such a great impact on the traveling straight lines of the ball. Pitching occurs because you have to upset the timing that the batter will expect. Rivera pitches to the upper left corner, which causes a lot of broken bats. Wakefield's knuckleball has unpredictable direction. This can be determined by analyzing wind tunnel data, high-speed video, tracking data, which is looking at how the air interacts with the seams of the ball. There is great variation in spin axis and the number of rotations, which causes a random chaotic system. And you can see in this video how much the pitcher's arm travels in order to get the right spin moving on the ball. Spin and angle. The spin of the ball and the angle the ball leaves the pitcher's hand are related. In a head-on collision, the same angle occurs as it came in with. and this can occur with a topspin grounder. Thank you very much for watching.